You might appreciate the fact that the film they used is not your standard Walgreens 35 millimeter or, Ektachrome that you can pick up. You'll find Mr. Hoagland will go into detail why they had specially designed film to use for taking the pictures of the moon and around the moon. Now back to what took place on Apollo 14. In my position as the manager of the Data and Photo Control Department, I would frequently get asked to check out various film strips that were taken by the Command and Service Module as it would circle around the moon, and so that scientists could look at potential landing sites or where we were at the time. There was a gentleman by the name of Dr. Thornton Page, and those who may have known him, he was a chief astronomer. He was in charge of the astronomy department within NASA. A gentleman, he wore a patch over one eye, very influential. He asked me to check out from the photo lab, which is a secret, you have to have a secret clearance to get past the front entrance area within the photo lab to go in the back. Of course, I had a secret clearance and I was able to go back there. As I walked in, I checked out the particular canister, which was, I've forgotten which orbit it was, but as they were going around on the back side of the moon, I took this film, and I was asked to do it because of my prior military experience with gun sequence cameras. As you know, you've seen some of the old World War II movies where they've got videos of the tracers going out and the dogfights that they would do. A camera, 16 millimeter, which would allow you to jump forward frame by frame or multiple frames, stop, freeze, zoom in, zoom out. And having that experience, Dr. Page, since I was the only one around, asked me if I would be willing to set up a private showing for him and the other astronomers. There were about 7 others. I took it over to the conference room next to the Mission Control building, set this up. We were watching the film. We were coming around on the back side of the moon, tracking towards a medium-sized crater called Tsiolkovsky. And if you'll realize that the moon from the Earth was in what you'd call half phase. We had a half moon, which means if my face is the moon and you're looking from this side, you'd only see the back half would be dark and the front side would be half lit. Same way on the back side of the moon, the sun was shining on half of the back of the moon and the other half was in shadow. On Tsiolkovsky, the shadow was casting over about half of the crater. So as the command module is circling the moon, we're approaching Tsiolkovsky, and in this darkened area in the corner of Tsiolkovsky, there's these 5 clusters of lights that look like domes that are illuminated in the shadowed portion of Tsiolkovsky. Dr. Page asked me to freeze. He asked me to back up, approach again a couple of times, to zoom in, zoom out. We took probably 10 or 15 minutes looking at that particular frame area of Tsiolkovsky. Dr. Page turned to the other astronomers and scientists and says, "Well, boys, what do you think?" They all chuckled and laughed like it was an inside joke. I found that rather interesting at the time. As a matter of fact, my brother was there in the auditorium with us watching it, so there are other people that were not part of the scientists that were present. Now, I took that, I was told to complete the showing. I did that. I took the film canister back to the photo lab, and as I was taking it in to check it into the lab, I walked through an inner room where there was a light table. Those of you who've ever looked at slides and you didn't want to put a projector, you can have a table with sort of an opaque cover over it and light shining on the back, and you could put your slides on top so that you could review and look at them as you go. Well, there were 3 people, 2 men and a lady were sitting there, and they were leaning over and they were airbrushing and they were painting on these negatives. And I asked the gentleman, "Well, what are you folks doing?" One of the men quipped very quick. He says, "We're professional strippers." The young lady there, I think, took issue with that. She said, "Well, actually, what we do is that we know, everyone knows that space is dark, and we don't want them to be confused with stars and things that might be along the horizon. So we're actually painting out the stars and airbrushing out along the horizon on the moon." Well, again, rushed, had to get things turned in and get back to my duties over at the LRL. I checked the film in, thought about this, well, I'll check it out later. The next day I checked out the same roll of film, took it to the main auditorium at JSC next to the admin building in the main auditorium there, where I was to show this film to the rank and file engineers at NASA. I had several other friends I invited to it. They were sitting back by the projector with me. As we were coming around the same film strip, coming on the backside of the moon, approaching Tsiolkovsky, I'm saying, "Guys, wait till you see what we saw on the backside of the moon." Here comes Tsiolkovsky. There's the shadow. There are no lights in the shadow. I froze the camera, stopped, turned it off, said I was having technical difficulties. I examined the film. It hadn't been cut, it hadn't been spliced. So within 24 hours, that film strip, and I can guarantee you, had to have been taken out, cut, painted out, spliced, and a duplicate copy made available for me to show the very next day. So first-hand experience in having come there. With that point, I think I'll turn it over to Mr. Hoagland to come in and discuss why that film that we used on the Apollo program was different from what you normally would use and why it became so significant. Last thing I didn't cover too well is when I went back to Oklahoma City University on January of 1978, I was back as honorary receiving the Distinguished Alumni Award and doing a presentation at their mid-year institute. At that time, I chose to break up that set that I had and make it a repository at OCU with Dr. Whitten, and the letters attest the fact that I had given him back the photos and other materials and kept them there in addition to those that I kept in my personal collection at home. So by chance, being at the right place at the right time, I hope I did the right thing in keeping the evidence and the information that can now bring things forward for the future. Mr. Hoagland.
And now things get interesting, because I'm going to show you what was on Ken's secret stash, what NASA never apparently wanted you or anyone else in the press, American people, Congress, or on the world stage to see. This is a spectrum. It's important to know that the human eyesight goes from around 4,000 angstroms down to 7,000 angstroms, a very tiny part of the electromagnetic spectrum. This is the visual response curve of what human eyesight, it peaks in the yellow-green, which roughly is where the sun output is highest. It falls off sharply over here in the violet and sharply over here in the red, and it peaks here. So if you want to see anything in this part of the spectrum, you got to do something to knock this bright light down so that your eye can actually see what's going on here or here. It's all about like me looking into that light, and I can't see anybody out there. This is important background physics for what I'm going to show you. This, as Ken said, is the Hasselblad camera. This was a German camera, high-end camera, modified by NASA for use in a vacuum, thermally shielded so that the temperatures on the lunar day, about 250 degrees above zero, would not fry the film. It was mounted on a bracket, and there's a trigger down here where the astronaut with his glove, those bulky gloves, would basically just aim with his body and shoot. And they shot a lot of film, and a little of it we have seen. Most of it we have not seen, and you're going to see why. This is the actual interior of the Hasselblad, showing how it functions. It had a detachable magazine in the back, which contained something like 200 pictures before they had to change the magazine. This is an example of how the color worked, red, green, blue, producing a color image, except this is film, not electronic. And this is the actual cross-section of the film itself. It has layers of emulsion, layers of gelatin, layers of stabilizers. It has protective coatings. Each of these layers is sensitive to a different wavelength of the spectrum because of the filters, the color filters, the dye filters that are embodied in the film itself. And the upshot is you create a reversal color image through this rather archaic and cumbersome mechanical process that was all too available to everybody until a few years ago when CCDs and digital technology has superseded it by and large. All of this is described in various NASA documents. This one is a survey of the photographic equipment and techniques authored by Albert Dare. And there are many of these you can find on the web. This was authored back in 1972. The point is that on Apollo 14, it turns out that perhaps one of the most important pictures, up until we looked at later missions, that had ever been taken and saved was acquired by Alan Shepard on the moon. And when he was ordered to destroy this and a lot of other of the film, Ken Johnston, young guy, pressed for time, in an incredibly energetic and ambitious and accelerating system,